She sells seashells by the seashore. Hello, we are live again here on the Lakeview School YouTube channel. How are you getting on, lads? I hope you're all keeping well and I hope you're enjoying the videos that the teachers and staff and everyone has been loading up in the last few days. So, boys, today I'm just going to do a quick one with you. It's a little science activity, a little experiment. And it's very simple. You can do it yourselves in your kitchen or wherever at home. You don't need a huge amount of resources for it. And the learning objective is to create an optical illusion using water. So we have a couple of words there, a bit of scientific vocabulary to get through. First, optical. So can you think about what optical might mean? Where do you think optical has come in? Or have you heard about it being used? So an optical is to do with your eyes, to do with your sight, the way you can see things, vision. So opticians, you go to an optician if you want to get your eyes tested, okay? So it's to do with vision and sight, light. And an illusion. So an illusion is something that you think is one thing, but it's actually something else, or something that's happening that's kind of tricking you into believing, that it's something that it's not. It's very hard to explain what an illusion is, to be quite honest, but magicians and illusionists are people who try and set up a scenario or set up an event that makes it look like something's happening. Like they might be trying to escape from a box that seems impossible to get out of, like a lock or something like that. So this illusion here is an optical illusion. So it's to do with kind of tricking your eyes into thinking that it's seeing something that's not actually happening, okay? And we'll be using water. So I've got H2O there in brackets, and H2O is the scientific name for water. So H2 with a small little 2 below means has 2 hydrogen atoms and 1 oxygen atom. So that's what it is, hydrogen, 2 oxygen. Right, so all you need for this, lads, is a glass, an empty glass. In this case, I got a glass jar. I think there used to be old olive or something in it. A jug of water. And you'll see in brackets I've got this sort of little sideways V with the big part of it sticking out, the open part sticking out. That means less than in mathematical vocabulary. So less than 500 milliliters. So if you see on the liquid mark there, it's got just less than 500 milliliters. I was holding it up, so that's why it moved along. So do you know another word for 500 milliliters? Another way of describing that? It's to do with liters. So how many milliliters in a liter? Think about that first. And how would you describe maybe 500 milliliters? So that'd be half a liter. Okay, so 500 milliliters is half a liter. You don't need that much water, but that's just giving you an example of how much water you can use. Also, guys, just need some paper and a pen or a marker. Alright? So, I'm just going to move over this for a second. I'm not going to go spend a huge amount of time doing it, guys, because I want you to have a little bit of crack trying to discover it yourselves. So, what I've done first is I have a little piece of paper here, if I can find it. That's it, Command Dave, throw that on the ground. And I've got 2 arrows pointing to the left. So what I'm going to do first is I'm going to try and set this up that it doesn't fall over, and then we'll be able to rock and roll and see if I can actually hold it up. Whoop. How's that look now? Not too bad. Whoop. Right, there you go. What a professional. Right, so I'm going to put this in here. You got these 2 arrows. You can see where they're pointing. They're pointing to the left. I'll just put the marker, I'll just put this pen down just in case you think I'm doing some sort of messing around or hiding or something. So I'll put the pen there, is to the left, so it's pointing that way. So they are pointing that way. So I'm going to get my jar, my empty jar, I'm going to put it in front of that like that, okay? Around here. And we'll see what happens to those arrows. You still see them pointing left, they're a little bit distorted because of the water. But let's see what happens now. I'm pouring it in. Pouring it in. Everything seems sound. Whoa! What's going on now, lads? It appears as though those arrows are now pointing to the opposite direction, the right. So what's going on? Seems a bit daft to me, but that is our optical illusion. So if you pull it, I'll try and bring it back towards, see what's happening. You can see that you're getting smaller. Lift it up, push it back a little bit. If I lift it up, what do you think might happen? 3, 2, 1. Well, there's the top one. Is that way? And there you go. So you can see this optical illusion. So they seem to be changing directions, and even as you bring it in there, you can kind of see it as it changes direction. So have a think about what's happening there with those 2 arrows. Why are they now facing that direction? If I take it away, guys, take away the piece of paper. I can leave the jar there beside it so you can see there's no magic water in it, lads. I can drink it in a minute if you want. There you go. I didn't change them around or anything. This is still the same piece of paper. Okay. And you don't just have to do with arrows of paper. You know, with words as well. So I've got this word here. You could probably nearly figure out what it is, but that's the way. There's no magic paper about that. So I'll clip that up again as well. So what do you think might happen, or what do you think might happen to those letters when I pour through the water? Any idea what you think may happen to those letters? Have a little think about that. Back into our jug. Line it up there. Oh, come on, Dave, you're missing it. There we go. Okay. I have a feeling that because this jug is a little bit too small, or this jar, this mightn't work properly, but we'll see. You never know. I don't know if I rehearsed it in the first place. Oh, there it did work. Yeah, so, hello. So let's have a little think about why that's happening, alright? And I'm going to let you know another trick here. I don't really know the ins and outs of the science of this, to be honest. And this is a kind of a teacher trick as well. If I suggest that you go off and investigate it yourselves, that kind of saves me sort of spoofing and pretending I do know what happens. What it is to do with is light going through the water and through that space of here. There's a space here of air. And what happens is that it's bending it away. The water is bending the light away. So it actually starts sort of messing up the way we see it. So what we see, the way we normally see things, if we're looking straight like that, when you start looking at it through another lens, as they say, and it sort of bends it away. Okay, so it's to do with that sort of, it's bending of light. Okay, so that's the kind of little hint towards what I'll say. But what I would like you to do is go off there and investigate it. See what you can come up with yourselves. Have a bit of fun with it if you want. See if you can come up with ways of, using it for, creative way at all. You could add a bit of, pictures to it. See if you can make pictures look the opposite way. That sort of thing. Have a little gander. I'm sure there's plenty of videos on YouTube of it, because I'll be honest with you, lads, I didn't invent this at all. But look, you can start having a goof around with it. Show it to your brothers and sisters, family, parents, whoever's around in the house at the moment. Okay? And have a good Easter, guys. Enjoy yourselves. Salon.